Hi there, my name is Jason Harlow. I am the Practicals Coordinator for Physics 151. What that means is that you have lectures taught by Professor Kushner on Monday, Wednesday, Friday, and then Professor Julian for the second half of the semester. But you also, on your schedule, should have a PRA, a practical section. That's a 3-hour block sometime during the week. And so that is going to be on a Zoom call that you'll be having with your TA, one TA for 18 students. And I am coordinating those TAs and coming up with activities for you guys to do online and at home during those practicals. So this first week, we're going to start in on one of the most important topics in physics and experimental physics, which is uncertainty analysis. So I want to share some slides with you. So almost every time that you make a measurement, the result will not be an exact number, but it will be a range of possible values. The range of values associated with a measurement is described by the uncertainty. Some people call this the error, but I think it's better to call it uncertainty. Example. Well, actually, this is a rare example would be when there's no uncertainty. So if you were counting 3 apples here, you would say there are 3. Clearly there's 3 and there's no uncertainty in that number. But almost every other number, even counted numbers, do have an uncertainty. For example, what if someone asked you to tell them how many apples are in the back of the truck, of this truck, and you looked at it and had to make an estimate or a measurement? If you didn't have the time to count them all, then there would be an uncertainty. And let's say you said there was 1,600 apples. You could say, it's better to say 1,600 plus or minus 100. So 1,600 is the value there, and 100 is the uncertainty. So what does that mean? That's what we're going to talk about. So uncertainties eliminate the need to report measurements with vague terms like approximately 1,600 or little squiggly equals 1,600. Uncertainties give a quantitative way of stating your confidence level in your measurement. If you say an answer is 10 plus or minus 2, what that means is that you are 68% confident that the actual number is somewhere between 8 and 12. And it also implies that you are 95% confident that the actual number is between 6 and 14. This is what's called the 2 sigma range. So here is a histogram of many measurements of the same thing. They don't always come out the same. So plus or minus 1 sigma represents 68% of the area under this, and plus or minus 2 sigma represents 95% of the area. So this is what's called a normal distribution. A probability distribution is a curve which describes what the probability is for various measurements. And the most important and widely used probability distribution is called the normal distribution. It was first popularized by the German mathematician Carl Friedrich Gauss in the early 1800s. So it's sometimes called the Gaussian distribution or the bell curve because it's shaped like a bell. This is the equation for the Gaussian. So if you're plotting number of measurements, n versus x, then n of x equals a, where a is the amplitude there, times e to the power of negative x minus x bar squared over 2 sigma squared. So a is the maximum amplitude. X with the little bar on the top is called the mean, or the average, and sigma is the standard deviation of the distribution. Statisticians often call the square of the standard deviation, sigma squared, the variance. Sigma is a measure of the width of the curve. A larger sigma means a wider curve. 68% of the area under the curve of a Gaussian lies between the mean minus the standard deviation and the mean plus the standard deviation. And 95% of the area under the curve is between the mean minus twice the standard deviation and the mean plus twice the standard deviation. So when making measurements, there's a roughly 68% chance that any measurement of a sample taken at random will be within 1 standard deviation of the mean, assuming that you have a normal distribution. Usually the mean is what we wish to know, and each individual measurement almost certainly differs from the true value of the mean by some uncertainty. So there's a 68% chance that any single measurement lies within one standard deviation of the value of this true value of the mean. So the value of sigma is often called the statistical uncertainty, and that's what you put for the plus or minus.